Hello, my name is Tyler Dunaway, and this is my Physics 2020 project for the University of Memphis on how the sun produces light and heat. The sun produces light and heat. It's important that we first discuss the origins of the sun and where we believe it came. Theory is the nebula theory, which is Latin for cloud. Basically, a bunch of hydrogen, helium, and other elements clump together in this giant mass. As they begin to clump together, they rub together with kinetic energy, which creates heat and immense pressure. And once these temperatures reach around 10 million degrees Fahrenheit, it becomes a process known as nuclear fission. This will kind of explode, and eventually all the outward pressure from this will prevent further collapse and of this gas cloud, and it becomes a stable ball of hydrogen and other elements that we know as a star, or as we like to say commonly is our sun. The creation of the planets goes along with the nebula theory. The result of the nebula theory is at first it becomes a protostar, and as this is happening, gases will spiral and form globes depending on their distance from the star, and they form things known as planetestrals. Their makeup depends a lot on their distance from the star. As these planetestrals are farther away from the sun, we see more icy makeups of planets, and they will continue to gather information. They will continue to gather material and form planets eventually once kind of all these gases have settled down a little bit. I would like to quote Pierre-Simon Laplace in my essay that I quoted, who summed this up kind of well when he said the sun originally had an extended hot atmosphere throughout the solar system, and that this protostar cloud cooled and contracted. As this cloud spun more rapidly, it threw off material that eventually condensed to form the planets. So in short, that's what we see as the creation of our planets. Now Earth, luckily as we know, falls in the habitable zone for life that we see in this blue area right here. This would be our sun, and this would be, had our sun been bigger, for different relative stars. As we see, if our sun was smaller than it is, we would have to be closer. And if it were larger, we would have to be further away, which is very logical. Now, life is very debatable on how we classify a habitable zone. Some form of life may not need the same kind of zone or atmosphere that we need to sustain life. So we generally accept this depends on the planet's atmosphere or its ability to retain heat from stars, if that was what the life needed, as we need. And life depends on water as well. So as we see in Mars, that's a planet known to have water, so we can explore possibilities of life on it. A fun fact about this, I guess you could say, is that I found that if Earth were to get 10% more radiation due to lessened effects of our atmosphere or things like that, we would be actually trapping more heat inside of our atmosphere, which would eventually evaporate the oceans and cause basically Earth to become a giant ball of humidity, which would be unavailable for life to continue. So I guess you could say luck, or by intelligent design, or whatever you would say, that our planet fell in the habitable zone, that we were able to develop life on it. In order to further discuss the makeup of, or what creates heat and light from the sun, it's also important that we know what the sun is made of. The nebula theory kind of touched on what this is as well, but the sun now, as it is stable, is basically a giant ball of hydrogen, and that's generally accepted as it makes up 70% of the sun. Helium makes up the other part of it, and almost negligibly there's oxygen, nitrogen, carbon, magnesium, iron, sulfur, and silicon also, but generally we can accept that it's made of hydrogen and helium. The sun generally falls in three layers, physical layers that we see, although it is made of plasma. The core, which makes up 25% of the sun's makeup, and then we have the radiative zone here, which makes up about 45%, and the rest we know as the convective zone. The photosphere and the chromosphere we will also talk about, although they aren't generally physical terms for the sun's makeup. The core is perhaps the most important part of where heat comes from that keeps us all alive. Basically, there's giant gravitational forces that pull hydrogen and helium in because of the size of it. Kind of similar to the nebula theory, the way that it happens, in a more balanced way. These hydrogen and helium particles will fuse together, and it causes a reaction that puts out heat, what we say is around 28 million degrees in the core of the sun. And this pressure is so immense that we estimate it to be somewhere around 250 billion atmospheres. It's also very important in noting that the sun's core is responsible for 99% of all the energy created in heat. The next zone that we see here outwards of the core is the radiative zone. There's no light or heat created in the radiative zone per se, but it does propagate energy produced in the core outwards to the convective zone. We will see a slight drop in temperature from the core down to about 12.6 million degrees Fahrenheit, and the radiative zone is also less than half as dense as the core. So there's nothing created in the core, but it does transfer the heat outwards that we see in the next zone, which is the convective zone. This is the sun's physical most outer layer, and we see a further decrease in heat as heat exits the sun. It is even less dense than the radiative zone, and because of that, it allows convective currents to be created, which will send heat outwards to the next layer of the sun, which is the photosphere that we will talk about next. The photosphere, while it's not a physical part of the sun as we see in the sphere, kind of denotes the fact that it's in the atmosphere of the sun right around it. So it's very close to a part of it, but it's still technically not a part of the sun per se. This is where heat and light are sent into the solar system. The temperature we see is around 7,600 degrees to 10,000 degrees Fahrenheit. This is where UV light comes from, where our visible light is created in the photosphere, and so that is the part of the sun that we see. That the innermost part of the sun, if you were to look at it, which you shouldn't, is going to be very clear, opaque, and as you move outwards the sun, you can start to see the outline of it, which is the photosphere. This is the part of the sun that we are able to see with our eyes. Next is the chromosphere, which creates mostly red light. It's the last place where hydrogen atoms are burnt off as they exit the sun's atmosphere. However, we can only see this light during a total solar eclipse, which is very rare. But as you can see in this picture, this is the red light that we see in the chromosphere, excuse me. So we only get to see this every now and then, but this is the red light that's created. But we cannot see the other light sphere, and the photosphere generally kind of drowns out the rest of this light because it's so much brighter than the light produced in the chromosphere. In conclusion, we can see that the nebula theory is responsible for the creation of our entire solar system. The sun, the planets, everything we know was due to this in theory as we generally accept through science. Earth is only habitable because of our distance from the sun and our atmosphere. If Earth was to be a couple thousand miles closer on either side, it would be too hot or too cold. So we fall in the habitable zone where water is able to be retained through our atmosphere, which protects us from protects us from harmful UV rays and kind of filters those out as they enter into our atmosphere. The sun is comprised of basically hydrogen and helium with negligible amounts of other elements as well, but for the most part we generally accept that it's made of hydrogen. The layers of the sun and their atmospheres have various functions in producing light and heat, with most of the light coming from the photosphere that is able to be seen, and most of the heat generated in the core. So as a result of all this, we get to live and breathe and enjoy beaches and suns and plant life and everything we know because of the sun. Here are my references that are also listed in my essay if there are any other further questions. That's all I have. Once again, thank you for listening.